Assalamualaikum and a very good morning to all my friends and my lecturer. Today, I would like to present to all of you Part B, Question 1 and Question 2. My name is Fatim Fasiha binti Kamarul Bahrain. Find and modify an application problem that can be formulate programming problem with at least 3 decision variable and 3 constraints. This question I and my group mate modify. Kit toy, Sendian Berhad use 3 operations to assemble 3 toys, which is car, bus and lorry. The delay available time for 3 operations 42, 40 and 45 minutes. The revenue per unit of the toy car, bus, lorry are Rm 240, Rm 220 and Rm 450. The assembly time per car at the 3 operations are 2 to 1 minute. The assembly time per bus at the 3 operations are 1 over 2 minutes. The assembly time per lorry at the 3 operations are 3 to 1 minute. Let's make Z equal 240 x1 plus 220 x2 plus 450 x3. Subject to constraint 1, 2x1 plus 2x2 plus 1x3 smaller than 42. Constraint 2, x1 plus x2 plus 1 over 2 x3 smaller than 40. Constraint 3, 3x1 plus 2x2 plus 1x3 smaller than 45. Constraint 4, x1, x2, x3 greater than 0. Solve the LP by using Lindo or Excel solver. I use Excel solver. This table I got from the Excel solver that I solve it. Variable cell. First, name. X1 I will name it number of car per week. X2 number of bus per week. X3 number of lorry per week. Okay. First objective coefficient. X1 240, X2 220, X3 450. The final value, which is final value used for X1 is 0, X2 36 and X3 2 only. We can see it available increase 200 for X1, X2 5, X3 210. Available decreased 1E plus 30 and X2 70, X3 10. Okay, next this is table constraint. First I will explain to all of you one by one. First operation A. Okay, constraint right hand side is availability. Operation A 42 and final value had been used 42 also. Available decrease is 2. They can be decreased to in right hand side to make profit maintain. Available increase 80, so it can be increased 80 unit to make profit increase. Okay, shadow price 10. If increase 80 unit, then the price must 10 to get profit. Okay, operation B. Constraint right hand side is 40. So the final value that had been used 42. Available decrease is 12. They can be decreased twice in right hand side to make profit maintain. Available increase is 2. so it can increase 2 unit to make profit increase. Shadow price. Shadow price is 210. If increase 2 unit, then the price must be 210 to get profit. Okay, operation C. The constraint right hand side is 45. So the final value that had been used is 20. Available decrease is 25. They can be decreased 25 in right hand side to make profit maintain. Available increase is 1e plus 30. So it can be increased 1e plus 30 unit to make profit increase. Shadow price. Shadow price is 0. If increase 1e plus 30, then the price must 0 to get profit. This one is car. Final value is 0. Allowance increase is 18, so it can increase 18 unit to make profit increase. Next, X2 bus. Final value is 36. Allowance increase is 36, so it can increase 36 unit to make profit increase. Next, X3 for lorry. Final value is 2. Allowance increase is 2, so it can increase 2 unit to make profit increase.
I will explain about question 3a, which is the changes on the right hand side. Okay, first, what need to do? The first step is need to find the optimal table to find the dual price and flexibility range. From this table, we can know the value of Z, which is RM 8,820 ringgit, and the select value for S1, S2, and S3 to find the flexibility range. Suppose that D1, D2 and D3 are the changes made in the daily manufacturing time of operation A, B and C. Thus, the kit toy model changed to X1 plus X2 plus 3X3 less than or equal 42 plus D1 for operation A. For operation B, 2X1 plus X2 plus 2X3 less than or equal to 40 plus D2. And then for operation C is X1 plus 1 over 2X2 plus X3 less than or equal 45 plus D3. After that, the new optimum table also provides the following optimal solution, which is row Z, row 1, row 2 and row 3. The objective function is Z equals to 8,820 plus 10 D1 plus 210 D2. The current solution remains feasible if all the basic variables non-negative. The feasible condition for row 1 is X3 equals to 2 plus D1 minus D2 more than or equals to 0. Row 2 is X2 equals to 36 minus 2 D1 plus 3 D2 or equal more than or equals to 0. Row 3 is S3 minus 10 S3 equals to 25 minus 1 over 2 D2 plus D3 more than or equals to 0. To know the maximum and minimum value of feasibility range, we use the table of sensitivity analysis as a reference. From this table, we need to refer at column constraint right hand side, allowable increase and allowable decrease. To know the minimum value, the formula is right hand side minus allowable decrease, while for the maximum is right hand side plus allowable increase. Based on this table, we can know that feasibility range minimum for operation A is 40 and maximum is 60. For operation B, minimum and maximum are 28 and 42. And last, for operation C, is maximum and minimum are 45 and 15. For question 1, the value must be in the feasibility range and the shadow price must valid. It is because to make the all conditions are feasible. Suppose that the manufacturing time available for operation A, B and C are changed to 50, 41 and 30. Then, we need to calculate the right hand side changes to get the value for D1, D2 and D3. D1 equals to 50 minus 42 equals to 8. For D2 is 41 minus 40 equals to 1. And for D3 is 30 minus 45 equals to negative 15. After that, substitute the value of D1, D2 and D3 in feasibility condition for x3, x2 and x3. x3 equal to 2 plus 8 minus 1 more than or equals to 0. And x3 we get equals to 9 more than 0. That means the equation is feasible. And then x2 equals to 36 minus 2 times 8 minus 3 times 1 more than or equal to 0. And the value is 23 more than 0. That means the equation for x2 is feasible. Then x3, 25 minus 1 over 2 times 1 plus negative 15 more than or equal to 0. And we get the value is 19 over 2 more than 0, which is feasible. So, all conditions are feasible. The new optimal solution by using objective function and substitute the value of x2 and x3, and we get z equals to 9,110 ringgit. The question for A2, which is suppose that the manufacturing time available for operation A, B and C are changed to 45, 38 and 18. The value of right hand side for S3, which is 18, is the out of feasibility range and the shadow price is not valid. Then we need to find the right hand side changes to get the value for D1, D2 and D3. For D1 equals to 45 minus 42 equals to 3, and D2 38 minus 40 equals to negative 2, and D3 18 minus 45 equals to negative 27. After that, we substitute the value of D1, D2 and D3 into the feasibility condition. The x3 equals to 2 plus 3 minus negative 2 more than or equals to 0, and x3 equal to 7 and more than to 0. That means x3 is feasible. Then x2 equals to 36 minus 2 times 3 plus 3 times negative 2 more than or equals to 0. x2 equals to 24 more than 0. So x2 is feasible. Then x3 equals to 25 minus 1 over 2 times negative 2 plus negative 27 more than or equals to 0. And the value of x3 equals to negative 1 less than 0. So x3 is infeasible. After that, so since x3 less than 0, the current solution does not remain feasible. So we calculate the optimal solution by using the dual price. Z equals to Rm 8,820 ringgit plus 10 D1 plus 210 D2. Then we substitute the value of D1 and D2 and we get Z equals to 8,430 ringgit. The dual price and feasibility range for the LP can be summarized as in the following table. Thank you.
Coefficient. If the objective function is changed, we need to find the reduced cost for NBV. This is the optimal tableau of the modified problem in terms of D1, D2 and D3. The NBV in this tableau is X1, S1 and S2. Okay, since this question is a maximum problem, so the reduced cost for NBV is greater or equal to 0.
Okay, for x1, 200 times 1 plus 0 times d3 plus 2 times d2 plus 0 times 0 minus d1 is greater or equal to 0. For s1, 10 times 1 plus 1 times d3 plus negative 2 times d2 plus 0 times 0 minus 0 is greater or equal to 0. For S2, 210 plus 1 plus, for S2, 210 times 1 plus negative 1 times D3 plus 3 times D2 plus negative 1 over 2 times 10 times 0 minus 0 is greater or equal to 0. Okay, this is the optimality condition corresponding for NBV X1, S1 and S2. Okay, next is the example when all conditions are satisfied. Suppose that the objective function of Kittel syndrome Berhad is changed from z is equal to 240x1 plus 220x2 plus 450x3 to z is equal to 250x1 plus 240x2 plus 482x3. Then we need to calculate the changes value of D1, D2 and D3. For D1, we will get 10. For D2, we will get 20. And for D3, we will get 32. After that, we need to substitute the value of D1, D2 and D3 into the optimality condition. Okay, this the optimality condition for X1, S1 and S2. Okay, then for x1 we will get 200 plus 2 times 20 minus 10, we will get 230. Since 230 is greater or equal to 0, then the condition is satisfied. For s1, 10 plus 32 minus 2 times 20 is equal to 2. Since 2 is greater or equal to 0, then the condition is satisfied. For S2, 210 minus 32 plus 3 times 20 is equal to 238. Since 238 is greater or equal to 0, then the condition is satisfied. Okay, since all the condition is satisfied, then this show that the purpose change will keep the current solution optimal and we will get a new value of z. So we need to substitute the value, the changes value d2, d3 into the z value, then we will get 604 ringgit. Okay, next is the example when at least one of the condition is unsatisfied. Suppose that the objective function of Kittel syndrome Berhad is changed from z is equal to 240x1 plus 220x2 plus 450x3 to z is equal to 255x1 plus 115x2 plus 225x3. Then we need to calculate the changes D1, D2 and D3. We will get D1 15, D2 negative 105, D3 negative 225. So we need to substitute the changes D1, D2 and D3 into the optimality condition. For x1, we will get 200 plus 2 times negative 105 minus 15. Then we will get negative 25. Since negative 25 is less than or equal to 0, then the condition is unsatisfied. For S1, 10 plus negative 225 minus 2 times negative 105. Then we will get negative 5. Since negative 5 is less than or equal to 0, then the condition is also unsatisfied. For S2, 210 minus negative 225 plus 3 times negative 205, then we will get 120. Since 120 is greater or equal to 0, then the condition is satisfied. Since we'll get two condition that is unsatisfied, then this show that the purpose change will not keep the current solution optimal. So we need to do further calculation. Okay, that's all from our group. Thank you.